Okay guys, for question number 1, under objective questions, there is a simple pendulum hangs in a lift. The lift then accelerates downwards with an acceleration which is less than the acceleration due to gravity. So which of the following is true? Okay, so we are talking about frequency, which is increases. The pendulum oscillates faster, amplitude increases, and period of oscillation increase. Okay, what do we have now? There is a simple pendulum and position in a lift. Then the lift is moving downward with some acceleration A, where A now is smaller compared to G lah. So in this case, as we know, the equation of period of any simple pendulum is T equals to 2 pi square root of L over G. And in this case, our G, we just change it with G prime. Why? Because in this case, the object is moving downward with some acceleration. So our G is not equals to 9.81 anymore. That is why we just change G to be G prime. So what is our values actually of G prime here? Okay, we need to find it. So by using the equation of Fy equals to MA, alright, so the object is moving downward here. At the same time, the force exerted on the pendular system now is the tension, also W, isn't it? Weight of the pendulum bob, also the tension exerted on the string here. So in this case, remember A is dominant. So any force equal direction with A now become positive lah. So opposite direction to A now become negative. So in this case, W equals to the direction of A. So W is positive, while T just in opposite direction of A, so T is negative, isn't it? So the equation is W minus T equals to MA. W minus T equals to MA. So by rearrange the equations, you will get T equals to W minus MA. So W equals to MG, then we just factorize M, you will get MG minus A. Alright, so from this equation, okay, G minus A now representing our G prime. Okay, where in this case G prime is smaller than G. Why? Because G is 9.81 minus by some values here, giving you okay to a value which is smaller than G, isn't it? So in this case, G prime now, which is G minus A, smaller than G. So what happened now? G prime is smaller. Based on this, G prime and T, they are inversely proportional, isn't it? So by having smaller G, then T is greater. Okay, so the answer is D. Okay, which is period of oscillation increase. When the period increase, what happened to the pendulum oscillation of the pendulum? Should be slower lah, because the period is greater. Okay, and then the frequency and T, they are inversely proportional. So when T increase, F should be decrease. So A is wrong lah. Okay, so the answer is D. Okay, for question number 2, a particle is in simple harmonic motion if it is at the equilibrium position. Which of the following statements about the velocity and acceleration of the particle is correct? Okay, so now we are focusing on equilibrium position. So as we know, at equilibrium, V is maximum and A equals to 0, isn't it? Okay, why? Because at the amplitude, the object needs to stop for a while so that V becomes 0. At the same time, A is maximum. Okay, we are talking about the acceleration exerted on the pendulum, where it just caused by the restoring force, isn't it? Which is F equal to MA. So at this position, the force exerted on the pendulum bob is maximum, which is the restoring force. That is why the object just turned back its direction to be backward. Alright. So in this case, according to this situation, at equilibrium, V is maximum and A equals to 0. So that the answer is A. Okay. For number 3, by giving you a body of mass 0.1 kilogram, okay, perform simple harmonic motion with maximum kinetic energy of 1 exponent -3 joule and amplitude 20 centimeter. What is its frequency of oscillation? Okay, so by giving you mass and then K max, also the amplitude. So remember, the amplitude should be in SI unit, which is meter. Okay, we just convert it to be in meter, and they ask you to find the frequency. Alright, so according to the principle of conservation of energy, E total, total energy equals to maximum kinetic energy, still equals to maximum potential energy. So in this case, maximum kinetic energy is half m omega squared a squared minus y squared. So as we know, K max at the equilibrium. So at equilibrium, y equals to 0, isn't it? So y equal to 0, giving you half m omega squared a squared. So as we know, omega equals to 2 pi f. Alright, so we just substitute all the values. M given already, which is 0.1. Amplitude given 2, which is 20 centimeter. Convert it to be in meter, 20 exponent negative 2 meters. Okay, don't forget about square here. We got square. Okay, and then this is E total. Okay, E total still equals to K max, isn't it? So 1 exponent negative 3. So by completing the calculation here, you will get the frequency equals to 0.113 Hertz. So the answer is B. Okay. Okay, next for question number 1, which is under structured question. Okay, a mass hanging from one end of a vertical spring perform vertical simple harmonic motion of amplitude 2 centimeter. There are 3 complete oscillations in 4 seconds. What is the acceleration of the mass at the equilibrium position, which is y equal to 0, and at the position of maximum displacement, which is amplitude? Okay, so what do we have now? By giving you an amplitude, so remember, we need to convert it to be in meter. Then there are 3 oscillations in 4 seconds. Okay, so they ask you to find the acceleration at equilibrium position, where y equal to 0, and at the amplitude, where y equals to y max lah. Okay, at the amplitude. Alright, so in this case, by giving you 3 oscillations in 4 seconds, we may calculate the period, isn't it? So period is the time taken for 1 oscillation. So for this 4 seconds for 3 oscillation, so that 1 oscillation equals to 4 seconds divided by 3. So you'll get period. So this is the period. And then omega equals to 2 pi over period. 2 pi over period calculated just now. Substitute into this equation, giving you omega. So omega getting out is 4.72 radian per second. So according to the definition of simple harmonic motion, we know that the main equation is A equals to negative omega squared y. Okay, so for the first one, at the equilibrium, y equal to 0. So when y equal to 0, okay, so we just substitute into this equation. Alright, so A equals to negative omega squared y equal to 0, so that giving you 0. Okay, and then for the second part B, A equal to negative omega squared y. So now we are talking about the amplitude. So y equals to A. So y equals to A equals to 2 exponent negative 2 centimeter. So we just substitute into this equation, where omega calculated just now is 4.72. Substitute into this equation 2, giving you acceleration equals to 0.445 meter per second squared. So remember, negative representing direction, okay, which is opposite to the displacement, or it always towards the equilibrium. Okay, so this is the way how to answer question number 1. Okay guys, next question number 2. Okay, by giving you the main equation of simple harmonic motion is x equal to a sine omega t. So they ask you to sketch a graph of velocity against time and kinetic energy against time. Alright, so basically by giving you x equal to a sine omega t. Okay, before that, don't be confused. According to our syllabus, we are discussing about y, isn't it? Okay, it means that the oscillation is just in vertical. But by giving you x equals to, okay, x seems like the oscillation now just on horizontal. Okay, still okay, still accepted here. Okay, alright, so x equal to a sine omega t. So remember, the graph given out is purely sine. What does it mean? The motion start from the equilibrium, then the object just oscillating and reaching the amplitude for the first quarter, and then stop for a while, turn back to its original position for the second quarter. After that, just oscillating to the left, now reaching the negative amplitude, the third quarter, and then turn back to its original position, which is the equilibrium for the fourth quarter. So complete already. One complete oscillation. Okay. So in this case, remember, purely sign positive means that the object starts from the equilibrium. And then moving to the right, turn back to its original, turn to the left, and then turn back to the equilibrium. Okay, so in this case, remember, at equilibrium, V is maximum. Okay, at the amplitude, V is 0. Still the same at the negative amplitude, V equals to 0. Okay, so they ask you to sketch a graph of velocity against time. So this is the graph, velocity against time. So remember, first we just start by the equilibrium, and because the equation given is purely sine for x. So to find V, we need to differentiate x with respect to t, isn't it? Okay, giving you a omega cos omega t. So the graph of V should be in purely cos and positive. So is it correct? Okay, so based on this equation, purely cos should be like this. Start from the amplitude, okay, and then going to the equilibrium, reaching the negative amplitude, turn back to equilibrium, and then turn back to amplitude again. Okay, so is it correct or not? Let's check it. Okay, first, okay, it just start by the equilibrium. At equilibrium, V is maximum, so we just start by V maximum, and then the object just reach the amplitude, so V equal to 0. Then the velocity equal to 0. Okay, turn back to equilibrium, then become maximum again. But remember, the motion now just directed to the left. That is why the speed is negative. Okay, and then reaching the negative amplitude, turn back to be 0. At the amplitude, V equal to 0. Okay, and then just return back to its original position, and the motion is directed to the right. So V is maximum and directed to the right. So V is maximum and positive and directed to the right. So the graph just be like this. So correct lah. The graph is purely cos. Okay, alright, and then they ask you to sketch a graph of K against time. Kinetic energy against time. Okay, so now remember, kinetic energy is under scalar, so we don't have any direction. That's why the graph always positive. We don't have any negative values for the kinetic energy. Okay, so K against T. Alright, at we just start by the equilibrium, so V is maximum. When V maximum, K also maximum, and then just reach the amplitude V0, so that K equals to 0. Turn back to equilibrium, V is maximum, so K maximum again. Reaching the negative amplitude, stop for a while, V equal to 0, so that K also equals to 0. K equal to 0. And then turn back to the equilibrium, then V become maximum again. V become maximum again. Okay, so first quarter, second quarter, third quarter, and fourth quarter. So K now we just refer to the speed actually. When V max, K is maximum. When V0, K equals to 0. So this is the graph of K against time. Okay. Okay, next question number 3. By giving you a graph, then the info given here is the amplitude, which is 5 centimeter. So again, we need to convert it to be in meter. Alright, and then the period. From the graph, you know that the period is 4 seconds. It's not 6, 4 seconds for one complete oscillation. Okay, so they ask you to find the amplitude, the frequency, the angular velocity, and the equation for the simple harmonic motion. So it's quite simple. Amplitude given already, so this is the answer. Frequency is 1 over period. Period is 4, so you'll get 0.25 seconds. Alright, and then angular velocity. Angular velocity is omega. Omega equals to 2 pi f. So 2 pi f is 0.25. Then you will get 1.571 radian per second. And then the equation is y equal to a sine omega t. So y equal to a, okay, equals to 5 exponent negative 2 sine omega calculated just now, 1.571 t. And don't forget the unit, okay, where y just in meter and t in second. Compulsory, okay, 1 mark given for the unit normally. Alright, okay, so this is the way how do we answer question number 3. Okay guys, next question number 4, by giving you an equation which is x equal to 10 sine 15t. So this is the main equation of the sympathetic motion. So they ask you to find the period. Also at 2 seconds, calculate its speed. Also explain about its direction. Okay, so as we know, the main equation is x equal to 10 sine 15t. So basically the general equation is x equal to a sine omega t. Again, we are talking about x, means that the motion of the object just on horizontal. Okay, all right, so based on this we know that amplitude equals to 10 and omega equals to 15. So omega equals to 15 and omega still equals to 2 pi over period. So based on this, we may calculate period directly, giving you 0.419 seconds. All right, and then for the second one, they ask you to find the speed. So as we know, to calculate speed, we need to differentiate x with respect to t, isn't it? So by differentiating the equation, you will get 10 15, 10 times 15, sine will be cos, so cos 15t, giving you 150 cos 15t, and the time given is 2 seconds. Substitute into this equation so that you will get v equals to 23.14 meter per second. And don't forget, for this chapter, the mode of the calculator should be in radian. Why? Because omega t here just in radian unit. Okay, so please check the mode of the calculator. It must be in radian. Okay, how about the direction? So v getting now is positive, means that the object is moving to the right. Okay, this is the way how do we answer question number 4. Next, question number 5. So in this question, the info given is the amplitude, which is 3 meters. The angular speed or angular frequency is 2 radian per second. At t0, the object located at the equilibrium. So y equal to 0, and it just moved to the right. Okay, so they ask you to find the period and then sketch a graph of displacement against time, speed against time, and acceleration against time. Alright, so according to the statement given just now, the object starts from the equilibrium, moving to the right, reach the amplitude, turn back to the equilibrium, and then oscillating to the left, reaching the negative amplitude, and then turn back to the equilibrium. Alright, so first they ask you to find the period. So omega equals to 2 pi over period. So that period equals to 2 pi over omega, and omega given already, which is 2 radian per second. Substitute into this equation and then you will get the period. So period getting out is 3.142 seconds. Okay, next they ask you to sketch a graph of y against t, v against t, and a against t. Okay, how is it? Alright, so y against t. Okay, so as we know, the equation is y equal to a sine omega t, which is y equals to 3 sine 2t, because omega given is 2 and the amplitude is 3. So the graph is purely sine. Purely sine should start from 0, reaching the amplitude, turn back to be 0, reaching the negative amplitude, then turn back to its original position, which is equilibrium, isn't it? So this is purely sine graph, and the amplitude is 3. This is amplitude, and the period for the time taken for one complete oscillation is 3.142 seconds. Okay, all right, and then for the speed, as we know, we need to differentiate the equations. So v equal to dy over dt. Okay, for the first differentiation of y with respect to t, okay, you will get 3 times 2 sine of 2t giving you cos 2t. Okay, 3 times 2 giving you 6 cos 2t. So this is the equation of v, which is equal to 6 cos 2t. And the graph is purely cos. Purely cos start from the amplitude, okay, towards the equilibrium, reaching the negative amplitude, turn back to equilibrium, and then turn back to its original position, which is the amplitude. So the graph is purely cos, and the amplitude is 6, representing our maximum speed. And again, the time taken for one complete oscillation is 3.142 seconds. Okay. And lastly, they ask you to sketch a graph of A against T, acceleration against time. So as we know, by differentiating V with respect to T, you will get A. A equal to dV over dt. Alright, so again 6 times 2 giving you 12. Cos, you will get negative sine to T. So the question is negative 12 sine to T. So the graph is negative sine, purely sine but negative. So the graph is negative and purely sine and negative, negative sine. And then the amplitude is 12. So 12 and negative 12. So 12 now representing the maximum acceleration. And the time taken for one complete oscillation is still the same, which is 3.142 seconds. So this is the graph of A against T. So remember, the amplitude should be different. This amplitude now representing maximum acceleration. Before this, the amplitude now representing the maximum velocity or speed. And before this is the maximum displacement. Okay, so be careful. We need to calculate this lah when they ask you to sketch a graph. Okay.